In this video, we are going to go over how to create the MONSUM1 entry for MSC Natsran. So this is what we can expect. By the end of this video, this is the entry we want to create. This is what we want to do. We want to take this load and find what the equivalent load is at the root of the beam. So that's the goal. We're going to do this with the MONSUM1 entry. Now, one thing we did before this video, we defined this other monitor point called MonPNT1. So if you saw the other video, what this monitor point is doing is it's summing up the applied load at these nodes. And then when you saw the previous video, you saw that the total load here was a negative 10,000 newtons along the y-axis. So again, that load was negative 10,000. This beam has a length of 5 meters. So what can we expect? We're going to sum up this a single monitor point. So what do we expect here? We expect the shear force to be 10,000 newtons, and we expect a moment of 50,000 newton meters. So let's go ahead and get started. Okay, so this is what I plan on doing. I'm going to show you how to create this MONSUM1 entry once. We're going to interpret the results. I'll put the data to a CSV file. I'm going to later on change the monitor points orientation. I'm going to talk about how to create maybe hundreds or thousands of these entries. And then all of this information is going to be sourced from the following references: the quick reference guide, the Natsran linear static analysis user's guide, and the aeroelastic analysis user's guide. These last two guides have sections devoted to monitor points. So if you want more information, I recommend referring to these documents. Okay, so let's go ahead and get started. So again, I am assuming that you have this entry, a MonPNT1. It could be a MonPNT3 or a MonDSP1, but here we're only considering this MonPNT1 entry. If I show you what that entry looks like, actually let me get the name of this. It's called P1. Let's go and look for it. I want to look for that MonP1 here. Let's go and see if I can find it. MonP1. I'm looking for the output for monitor point 1. I don't know if I'll be able to find it here. Oh, here it is. So this is currently the value for that monitor point. So it's negative 10,000. Again, we want to determine the equivalent loads at the root. So let's go ahead and do this with the MONSUM1 entry. There's an existing MONSUM1. So I'm going to delete that existing MONSUM1. So let's go ahead and create a new MONSUM1 entry. So we'll call this maybe P901. And we'll call this loads observed from the root. Let's go ahead and position this monitor point. So I know that at this location, I've done this exercise before, so I know that this point here is at 0, 0, negative 2. So let's go ahead and position that at 0, 0, negative 2. And now here, there are two formats to this entry. There's this format and then the second format. I'm going to show you how to use the first format. So that would be this option. So the first format is available in group 1. The second format is available in group 2. So let's go ahead and use group 1. So we want to output value. The monitor point is going to report values for 6 components. This is going to be for monitor points from a linear statics analysis. And then here we'll go ahead and use monitor point P1. So if you remember, this monitor point is P1. So we're going to use this monitor point in the summation. And then we're going to consider all 6 components from this monitor point in the summation. And then we'll use a coefficient of 1. So let's go ahead and do one more thing. Let's go ahead and look at the preview actually. So to look at a preview of the monitor point, turn on the model display panel, look for MONSUM1 P91 P901, which is the monitor point we just created. Mark this checkbox and the second checkbox, and then mark the third checkbox. So here we see a few things. One, we get a label telling us where the monitor point is. The square marker indicates the position of this monitor point. This coordinate system represents the coordinate system of that monitor point, if you will. This dashed line tells us which monitor point is included in the summation, and you can see that the dashed line is going towards this monitor point. So let me see if there's another monitor point I can show this with. Let's see. I don't know if I want to do that. Let's briefly demonstrate this for an additional monitor point. So say you want to include this monitor point in the summation. How would you do this? You would add another row. The reason you would use another row is because this is a monitor point 3 entry. And then you would go and select a monitor point, BP1, I believe it was. Let's go ahead and see if we get an update here. Okay, so now you see we have a new dash line. So this summation monitor point is now including this monitor point and this monitor point in the summation. But here, we're not considering this monitor point. So I'm not going to consider it. I'll remove it, and then the monitor point for the summation is updated. Okay, so here, let's go ahead and do this. Let's add the summation again, or actually let's leave it like that. Here you would think multiplying this by 5 would be enough, but you'll see what's kind of off about this in a moment. Actually, we'll just use 1 for now. Let's go and download this, or let's run this with Natsran actually. So again, we want to know what the load is when it's observed from this point. Here, let's look at the F06 file. And then the name of that monitor point is P901, which would be this one. So let's go ahead and copy that here. So this existing table of values, these are the values for this monitor point. This one in blue dashed lines. I've copied the data for the summation monitor point, which is P901. So you can see we get the same values. One thing that's missing here is we're missing the moment. The moment when it's observed at the root should be 50,000 newtons. Let me think about this. It should be negative 50,000 newtons. So it should be something like that. But when you read the documentation here, let me see if where can I find this? There is a remark saying that the moments, or is it in here? Right. So if you look at this other monitor point, MONSUM1, linear combination of 2 or more monitor points with moment transfer. What about MONSUM1? Here it says linear combination of 2 or more monitor points. It does not say it supports moment transfer. So here, even though the supply load is 10,000 newtons, it's 5 meters away from this monitor point. The moment should be about 50,000 newton meters. We see that in the calculation, that's not what we got. We actually got 0. And that's because this monitor point doesn't support moment transfer. Okay, so the one thing we see here is that now, since we only included the one monitor point, we see that the value, the applied load of negative 10,000 newtons is here. Now look what happens when I scale up that monitor point by 2. Let's go ahead and rerun this. We'll delete the old summation monitor point, P901. And then let's go ahead and look at the F06 file. And we'll look for P901. Here it is. Since we scaled the summation by 2, instead of negative 10,000, we now get negative 20,000 newtons. So that's an idea of how to use the first format. Now, what about the second format? I'm going to use the second format to yield the same value of negative 20,000. So to do this, let's go back here. Let's create a new entry. Scroll down a little. So again, group 1 is the first format. In group 2, this is where you can configure that alternative format. So let's go ahead. Oh, nope. I want to do this for the second row. So let's click on add row here. And then here, let's go and select mon pnt1. We'll consider all 6 components. Let's go ahead and use mon pnt1, all 6 components. And then we will repeat this. So let me supply a coefficient of 1. So now we want double the value. So let's go ahead and add the same monitor point here. And let's run this. Oh, let me update the name of the monitor point. So we'll call this P902. And then we'll look in the F06 file for the latest values of the monitor points. Oh, it seems I got an error. Okay, MONSUM1. Okay, so let's see if we can diagnose what's going on here. Oh, right. So I forgot to provide a position. That's bad. Okay, so let's go ahead and type in -2 here. And let's rerun this. Okay, perfect. So we'll look at the F06 file. We'll copy the new values for the monitor points. So here was the old P901. Now we have P901 and P902. P901 was using the first format of the entry. P902 is using the alternative format. So here in the second format, we listed the monitor point twice. So this is the same as adding the monitor point twice. And let's confirm this with the results. So for the first P901 monitor point, we got -20,000. And then for the second monitor point using the alternative format of the MONSUM1 entry, we also got -20,000 newtons. Let me show you another way to create this entry. So let's go ahead and use P903. We'll call this P903. Let's go ahead and give this a location. So we'll use -2. And then we'll go ahead and use the second format, the alternative format. And here, let's go ahead and do this. This is all coming from point 1, 1, 2, 3, this point, and then I'll create another row. We'll leave that blank. We'll say I'm on PNT1 here, and then 1 and 1. So this third format, or this third entry, it's the same as the second entry. So here, let me show you what the difference is. Let me copy this here and here. So this was the first format here on the top. I'm not a big fan of putting the multiple monitor points on the same row. So what I did in the other format is I moved it to the other line. So something like that. So I like this format more than using this format. Because then when you have to debug, it gets very confusing trying to interpret each line that has 2 monitor points. So again, I prefer to split it up into multiple lines. In monitor point P903, that's what I did. And we ran it, and let's look at the results. We'll see the same results. I just want to always prove to you that we are getting consistent values here. So for P903, we also get -20,000 here and here. Okay, now let's talk about a few more things. What do these axes and these new axes mean? Okay, so let me let me focus on P903. So here what I can do is only consider the second component of this monitor point in the calculation. So only consider the y component here in this case. We know it's the second component because here the green axis, that would be the second or the y component of that monitor point. So here I'm saying only extract values from the second component of that monitor point and include it in the calculation. Here what I can also do is say, actually let's do this. I'll say only consider values from the X component. This monitor point has a value of 0 for the X component. I think I have that listed here, right? So monitor point P1, so that again is this monitor point. So monitor point P1, the X component, this value along the X axis is 0 because there's no load on that axis. So you see it reported here as 0. Now, what we did a moment ago, we said in the summation, only consider component 1 from that monitor point, which is 0. So when we look at the new P903 monitor point, look what happens. This was the previous P903. Oh, here. And this one was the previous P903 that considered all 6 components. But look what happens when I only consider the first component. You'll notice that the force along the y-axis is 0, and that's because we did not select component 6 here, or component 2, sorry. Now look what happens when I select component 2. We'll run this, and we'll look for P903. Let's go ahead and jump up to the F06 file. And we'll look for P903. That would be this value. So before, when we only consider this component, component 1, you notice all the other values were 0. But now, when I consider component 2, now I get a negative 10,000 newtons here. Okay, now we know what axis is. It's controlling what values from the monitor point are in the summation. Now, what does new axis mean? This just controls what components in the summation monitor point are available. So here for new axes, I've only selected component 2, so it's going to only report CY. So here I have new axis set to 2. Let's go ahead and run that real quick. And then let's go ahead and look at the F06 file here in a moment. So let's go here, here, and here. Right, so let's go ahead and copy this table here. So P903 was, let me undo this. So this is what P903 looked like a moment ago. So we had, for the summation monitor point, we have 6 components. But since I only selected component 2, I only get CY component 2 reported. So let me sum this up. New axis controls the components that are reported. So here I selected 2. I only get component 2 listed and reported here. Axis controls which components of the monitor point are included in the summation. Okay, now I'll say this again. I've said this multiple times in the other videos. I know many of you might be tempted to read the F06 file and extract the data for the monitor points. I'll say it again that this is extremely difficult if you have hundreds or thousands of subcases. Here, what we can do, instead of going through that painful process of writing scripts and reading the F06 file, we're just going to open this in the HDF5 Explorer. Here, this summation, I believe, would be contained in MONPNT1. So here we have monitor points 901, 902, and 903, the ones that we created in this tutorial. Here, I'll click on Download CSV, and then on my desktop, I have a new spreadsheet. Let me close all these old windows and let me reopen this. And let's go ahead and look at the value. Let me see where we're at. So it would be these values here. So here you see the values of negative 10,000, negative 20,000, basically all the values we've been looking at. All the values we've been looking at in these tables, that's now in the CSV file. And you'll notice that I did not have to create a custom script to go in here and get the subcase numbers and the points and so on. All of that is already available in the H5 file. We just need a good tool to read the H5 file. Here on the far right hand side, you'll see subcase 1 is listed here. That's also carried over to this column, subcase 1. So if I had 2, 5, 100 subcases, each row would have the subcase number associated with this. So this is a big time saver if you ever want to get this data to CSV file. If you want, you could throw this in a report and be done with it. Okay, let me see where we're at with the agenda. So I created one monitor point. We interpreted the results, right? So in addition to looking in the F06 file and looking at the values here, in addition to looking at the values in the values in the HDF5 Explorer, you can also look at the values on the model. So for this, we'll go to Post. We'll look at MonPNT1. We'll turn that on. And let's look at component CY. And then we zoom into this monitor point. We see that we have, let me think here for a moment. Let me hide all the monitor points actually. We'll hide all of these. We'll look at maybe monitor point. No, I need to look at MONSUM. So we'll look at MONSUM 903. And I already forgot what MONSUM P903 is. P903. It's negative 10,000. Let's look at monitor point P902. So we'll look for P902. We'll turn on this. We'll turn on the label, confirm that's P902. And then let's look at the beam element site. For some reason they were hidden a moment ago. Let's go back to post. Okay, so for P902, we see that along the second component or the y-axis is negative 20,000. Here, if we look carefully, this blue marker represents negative 20,000. Now, how do you display arrows? Here in this option, this button, arrow plot, when you turn that on, let me go ahead and hide some of the beams here, the 2D elements. Here, when we turn on arrow plot and marker plot, we select component 2, we see that this is the direction of that force, if you will. It's negative 20,000 newtons. So again, in this monitor point, we took the values from this other monitor point and we doubled the values. So that's why we get negative 20,000 instead of negative 10,000. Okay, one other thing. Suppose you want to, I don't know if I have this, we'll see if I do. Suppose you want to orient and position this monitor point. How do you do this? Okay, so elsewhere, I have this other coordinate system here. And you can see the orientation is a little different. We want to move the monitor point and we want to orient the monitor point. So let's move the monitor point real quick. This is P902, so we'll go ahead and look for MONSUM1, P902. So P902 would be this monitor point. Let's move it to maybe negative 3. So let's go ahead and move this to negative 3. So this is the existing monitor point. Let's move it to negative 3. So now it's going to be in this region somewhere. So this is our newest one. Now let's update the orientation. So this is where we select a different coordinate system. And you'll see the orientation is different. So you'll notice that this orientation is not parallel to this coordinate system that we use. Now, when you rerun this, the output for P902 will be different. Let me see if I have, oh, so here's P902. Let's copy that to a different window. Since the orientation is different, the the values are going to be observed in a different orientation. So the components will be different essentially. Okay, it's P902. Let's go ahead and extract that table. Oh, that's interesting. I need to make sure I did this right. Maybe there's a misunderstanding on my part. P902, let me rerun this. I was actually expecting the values to be different. CD1. Okay, interesting. So when I did this again with the different oriented monitor point, I still get negative 20,000. What I was expecting here was that the values would be slightly different. Something like that. I'm just making it up here, but the values would have been different since the orientation of that monitor point is a little different. So this is what I'll do. I'll hold off on that comment. I suspect that the true answer is buried in the remarks. So I'll leave that discussion off to a different day. I think the goal here was to give you an idea of how to use the MONSUM1 entry. Let me go back to my agenda and see where we're at. So we outputted the results. We tried to change the orientation. And let's look at another comment. How do you create multiple ones, right? So sometimes doing all this in the web app is a little difficult. Let me do this. Let me show you an alternative method to do this. Well, say we wanted to use this format. We wanted to add additional monitor points. How would we do this? On the right side is a button to download a CSV file. Let's go ahead and download that CSV file. So that gives us this table group I CSV file. So here, what I can do, let's go ahead and add this. Let me see, how many times should I add this? Let's go for 20. So 22. Let me look here. Right, so let's go and do something like this. So we're summing the same monitor point 20 times. So we expect to get something like 200,000 newtons. Because remember, this has a value of 10,000 newtons on the Y component. Okay, let's save this. Let's import it back here. Let's go ahead and upload that CSV file. And then if we look at, this is what my new entry looks like. And I don't know if I mentioned it in this video, but you can use the web app to build your monitor points, paste it in a text file, and then you can import this to Patron, MSC Apex, or whatever other tool you happen to be using. Okay, so let's go ahead and rerun this. And I did this. Let's look at P901 because that was the monitor point that was adjusted. Okay, so this is P901. Let's see if I get P901. Okay, right. Great. So this is going to make my life a little easy. So here, this is the output back when there was only one monitor point in the summation. So we got a value of negative 20,000 newtons. Now here, after I use Excel to repeat the summation 20 times, and then I imported the entry and reran this, this is the new output. And then here you'll notice that we now get a value of 200,000 newtons. So this was 20 times the 10,000 newtons. And where the negative 10,000 was coming from that one monitor point. So let me display that monitor point 1, P and T1, this one. So we included this monitor point in the summation. We repeated the summation 20 times. So now we're getting 200,000 newtons instead of the 20,000 before. Okay. And again, if you want to, you can output this a CSV file. You would go and click the HDF5 Explorer. You would go to acquire data set. You would select the MONPNT1 data set here for P901. You notice that now the value for component 1 or component 2, this column here, is negative 200,000. So now you could download a CSV file. Let's confirm this. If we look in there, this is the monitor point we just adjusted. We multiplied this value. We added the value 20 times, so now we get negative 200,000 newtons. So that's confirmed in this CSV file. Okay, so I think that was the last thing I wanted to cover. How do you quickly modify that entry if you have to do the summation for dozens or hundreds of monitor points? That's okay. You don't have to do it all in the web app. You could download a CSV file, configure the summation here, import this data back to the web app, and then you can run Natsran and get the result that you were looking for. Okay, now one last thing, my contact information. So just in case you have a question or comment, you can reach out to me in this email address. And as a reminder, this web app, if you want to go ahead and practice what you saw today, this web app is available for free at theengineeringlab.com. So if you visit this website, at the top right hand corner is a blue button for a free trial. Fill out the form, and we'll go ahead and give you access to this web app so you can go ahead and practice how to create monitor points on your side. Okay, with that, thank you so much for watching.